Welcome to video 2 of section 2. Theano, one of the most popular ways of doing deep learning with Python. After the previous video, you are probably thinking that now we'll have a chance to dust off our calculus books to calculate all those derivatives. I'm sorry to let you down here, but differentiations can be automated with Theano. Because I really like automatic differentiation because it makes the development of deep architectures much faster and more correct. In this video, we will talk about what is Theano, see how to create Theano functions, and finally, how to automatically differentiate these functions. Let's go see Theano's website real quick. It's deeplearning.net/software/Theano. First of all, Theano is not a deep learning library. It is more general than that, and it is used beyond deep learning. As we can see here on the top, Theano is a Python library that allows you to define, optimize, and evaluate mathematical expressions involving multidimensional arrays. Theano will create functions that will be optimized and compiled to run on CPU or GPUs. Now let us move to our IPython notebook and write our first Theano function here. In this first cell, we have imported Theano and NumPy, which will be the libraries that we will use for our example. In Theano, we start defining symbolic variables that we will use in our functions. For instance, here, I will start by defining a symbolic matrix X. Think of those symbolic variables definitions like variable allocations in static languages like C. We define this variable, and then using the variables, we can define our functions. In this case, I'm defining y as x squared. Then we can use Theano function to compile. Let's run this real quick. And then we can generate a NumPy array. Let me define a NumPy array here, x, and apply our just compiled function to x. Now let us print our results. Here, when the x's inputs are 3, the squared of 3 are a bunch of 9s. We have a matrix of 3s, the output is a matrix of 9s. Pretty simple, isn't it? Okay, but I promised you to automate the process of calculating derivatives. Let's do that real quick. Let's define z as the derivative of y with respect to x. T.grad is what calculates our derivatives with Theano. And then, now that we calculate z, we can compile it as well, alongside it, y. So let's run this cell again, and then calculate our new values. Now f will return both y and z. Okay, let's run this cell, and then print the values of z alongside the values of y. Here, the derivative of x squared is 2 times x. 3 squared 9, 2 times 3, 6. Okay, again, so how a Theano function works. We define a symbolic variable, and then we compile the symbolic graph. After that, we pass a value to this compiled function that moves our NumPy array to a specific position in memory to calculate the compiled graph. Notice that we are moving variables from different positions in memory. But Theano also has the concept of shared variables, so we can move data beforehand to memory and leave it there. This is useful when using GPUs, so we don't have to move our neural network back and forth, consuming GPU bandwidth all the time. We'll see how to change parameters in the GPU memory without having to move values back and forth in the next video. In this video, we did an introduction to Theano and follow up compiling functions and their derivatives. In the next video, we will optimize a simple model using pure Theano.